Friends, in this video we are detailing study about the crane and hoist drive. So let's begin. So first of all we can understand the basic concept of the hoist. So friends, first of all we can understand what do we mean by the hoist. So hoist is a device which will be used for the lifting and lowering the loads. So friends, as shown in figure, there is one person who will be handling one device that will be called it as hoist. So friends, this is called it as hoist. And what was the purpose of that particular hoist? So as shown in figure, there are the different metal sheets are there. So this person will basically handling this type of the hoist for lifting and lowering that type of the sheets. Maybe that the sheets are the metal sheets. So this is the device which will be called it as hoist. And in industrial applications, in various types of industry, such manufacturing industry, process industry, we want to lift a load at a different location, different direction, or we call it as a different applications. So for the sake of that we have to use such type of device that will be called it as hoist. And for the sake of that particular hoist, we can see that we are using one of the motor, and that's why this is called it as hoist drive. So basically hoist is a very simple device which will be used for only moving, not a shifting. So a hoist is a simple device can only move loads vertically. So friends, as we've seen that this is the device which will be called it as a hoist. So this device only lift the load vertically, not a horizontally. So such type of the device which will be called it as hoist. And the second type of device which will be called it as cranes. So as we've seen that friends, what do you mean by the crane? So this is the crane. So crane is a device which is used for moving the loads in different directions. So friends, basically in the industry we are using both cranes and hoist simultaneously for driving a particular load. So friends, as shown in figure, this is one of the type of crane that we are using. So as we seen that this is the crane. So we are using one type of crane. So this is the structure of all the crane. So as shown in figure, there are the different types of the metal rolls are there, and this is the person which will be basically operating this type of the cranes. So this is a remote from which the person will be changing the direction of this particular crane. So friends, this crane will use for moving the loads in different directions. So friends, in concern with the hoist drive, just we have to use this drive for the vertical direction, but for the sake of the crane drive we are using this crane drive for your horizontal direction. So friends, this is the difference in between crane and hoist. So in the industry we are using both the combination of cranes and hoist for a particular purpose. So this is called it as crane. So what is the difference in between crane and hoist? So basically crane will be operated in a vertically as well as a horizontally direction, but the hoist will be only operated in a vertical direction. So that would be the basic difference in between cranes and hoist. So friends, obviously for the use of that particular crane, again we are using the different types of drive. So let's begin. What are the different types of drives? What are the different selection criteria for a particular industry while we are using a different types of cranes and different types of hoist for a particular application? Okay, so let's begin. So friends, as shown in figure, there are the different types of the cranes and the different types of the hoist that we are using for the industry. So friends, as we seen that this is one of the image of that particular industry. Such type of the cranes are basically used in the different types of the steel industry. Such types of drives are used in the different types of the pipe industry for the lifting of load. So such type of drives are basically used in the different types of the manufacturing industry, such manufacturing of your motor, manufacturing of your heavy machinery. So such type of the cranes are used in the industry. Similarly, this is the another type of the crane that we are using for the different types of industry. Such industry will be called it as a paper industry or the oil industry. And this is one of the type of drive basically used for the lifting of the different types of the pharmaceutical industry. So these are the some of the images by which we can get the actual applications of the different types of cranes and hoist for a particular location. Again friends, we have to see there are a lot of applications of the cranes and hoist. So friends, as shown in figure, this is called it as a shipyard. So this is a very big ship. This ship is basically used for the transportation purpose. So as we seen that there is a one mechanism, that mechanism which we call it as a, so that the particular application will be showing. So friends, this is a hoist. So as we seen that, what do you mean by the hoist? The hoist is a simple device which will be used for lowering and uppering the various types of the objects. So friends, this is called it as hoist. And friends, as we seen that this is called it as crane, because friends, while we are moving that particular load or the object, we have to use a crane. So as we know that the crane will be operated in horizontally as well as vertically direction. So friends, this is a combination of that we are using both cranes and the hoist for a particular application. So friends, as we've seen that this is very popular, the applications of cranes and hoist, and the size of these cranes and hoist will be very larger. So this is one part, this is second part, this is third part. So when we are using the first part, it is for the long distance. When we are using for the short distance, so that is the second and third. So this is one of the best example for the understanding why we are using the cranes and hoist for a particular application. So we are using the different types of machines or motors that we are using here, some of the motors that we are using here. So this is basically operating of your cranes and hoist. Now friends, again we can see what are the different applications of cranes in the different purposes. So this is one of the applications of cranes that we are using for the small railway system, that will be used for the maintenance purposes, for the lifting of purposes. So for the sake of that, we are using one type of crane. So this is another crane example of your drive. So this is another example of your crane. That crane we are using for the basically mechanical work that will be carried for to your electrical system or the civil work. So this is one of the type of crane. This is the another type of crane that we are using in the different type of industry that we had already discussed earlier, for the use of the pipe industry or for the manufacturing of the different larger civil structures. Such type of again drive we are using. So friend, this is again one of the type of crane that will be using for the lifting of loads for the heavy machinery. So as we seen that this is the another type of cranes that we are using for the lowering and moving the object in the different directions. So that's why we are using one of the crane. This is another portable crane, that type of crane that we are seeing in the day-to-day life for the different type of purposes. So these are the some of the applications of the different types of lifts and cranes. And for the driving of that particular lifts and cranes, we are using friends the different types of motors. So let's begin. What are the different requirement of that particular motors for a particular application? So friends, the first requirement for the crane and hoist drive. So the first requirement is that the motion of the crane hook is in all three dimensions. So as we seen that friends, we have to discuss, as we seen that the particular example. So if you want to move that particular object, so we have to use that type of the hook that we are using. This is the hook that will be moving in all three directions, because as we know that while we are using such type of cranes and hoists, so the applications that the cranes and hoists which will be look like that, we have to move that particular object in a any direction. So it will be a three dimensions moving hook is required. So this will be the first requirement. So what should be the second requirement? So the second requirement will be is that in crane drives, the acceleration and retardation must be uniform. This is more important than the speed control, because friends, while we are using a crane, we have to lift load and just put the load. So we have to get various types of the accelerations, because we have to gain that particular load into a particular direction, and as well as while we are putting that particular load at a particular site, so we will require a retardation. So in while we are using a drive for the cranes and hoist, so we have to take very important point into the consideration. This is called it as acceleration and retardation in spite of the speed control. So this is very important requirement while we are designing or while we are selecting a particular drive for a crane and hoist drive. Then the third requirement will be for the exact positioning of the load, creep speeds must be possible, because as we seen that in various applications like different manufacturing processes, we have to put some of the object at appropriate place. So the positioning control is very very important while we are selecting the cranes and hoist drive for a particular application. Then the next and very important requirement is that when the motion is in horizontal direction, braking is not a problem, but 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 the direction is vertical, so at that time the braking will create very very important vital role, because as we seen that while one object will be moving towards the downward direction, so due to the force of gravity, it will create some of the damages. So friends, while we are selecting the cranes and a hoist for a particular application, the speed must be constant while lowering the loads. So this is very very important requirement as concerned with the cranes and hoist drive. So the drive must have high speed in both the directions. So the motor must have high speed at light loads, because as we seen that while we are lifting the load, there should be a very larger load, but after lifting that particular load, while we are putting the load at the particular application, at that time the speed of that particular drive should be low. So for the sake of that, we have to use such type of motor or such type of drive for a particular application, so which will be having high speed and light load. So this is another very important requirement while we are selecting cranes and hoist drive. So next requirement, that is the mechanical braking must be available under emergency condition, because friends, as we seen that such type of cranes and hoist are used for the various applications, and in an industry there should be a emergency. So obviously while we are designing such type of the cranes and hoist application, so the drive must possesses the mechanical braking. So this is very important requirement while we are designing or selecting a cranes and a hoist drive. Then the next requirement regarding the cranes and in a hoist drive will be like that the power lowering may be used when an empty cage or light hooks. So as we have seen, while we are using for the braking system, while we are using for the light lowering system, so again the important parameter is that is a power lowering may be used. So obviously while we are selecting a cranes and a hoist drive for a particular applications, we have to check whether power lowering may be possible. If the power lowering will be possible, then this drive will be suitable as an crane and hoist drive. So these are the some of the requirements while we are designing a cranes and hoist drive. So let's we can check what are the different types of the operations which will be required. What are the different types of drive? So friends, there are the different operations in concern with the different types of the industry. So these types of the cranes and hoists that we are using drives in various application, and depending upon that we are just finding out some of the operation by which we will require some of the type of the drives as in motor. Okay, so the first operation which will be called it as hosting and lowering. So for the sake of that particular operation, because this is very important operation in the different types of industry, and for the sake of that we are using the AC slip ring induction motor and wide Leonard controlled DC motor. So this is the first type of drive that we are preferring for the operations of hosting and lowering. Then the second type of the operation which will be called it as crane travel. So in the crane travel we have to just traveling the cranes in the different direction as per the requirement. So for the sake of that we are using the AC slip ring induction motor for a particular application. So the third application will be trolley travel. So as we seen that in the different types of the countries we are using such types of cranes for a particular trolley travel. So for the sake of the trolley travel we are using the AC slip ring induction motor. Along with the AC slip ring induction motor, sometime we are using for the travel rural. So this is called it as a squirrel cage induction motor as well. So this is the another motor that will be we are using for your trolley travel. Then the next type of operation which we call it as slew and swing action. So when we will require slew and swing action, because in some of the industries like the different types of the oil industry or the different types of the chemical industry, we will require such type of action, and for the sake of that particular action, again we are prefer AC slip ring induction motor or DC motor. Because friends, as we seen that while we are using such type of industries, that is the cranes and drive, because these cranes and hoist are now modified by the use of the AC motors, because in previous days we are using the DC motor for that particular purpose, but nowadays we are using the different types of AC motors for that particular application. Then the last type of the operation should be called it as boom hoist, and for the sake of that particular boom hoist, again we are preferring the AC slip ring induction motor. So friends, as we seen that for the different types of the operation in the cranes and hoist, we are using the different types of drives. Such drives may be AC drives and DC drives. Nowadays, again, in spite of this particular operation, again there are the certain application according to the different types of load requirement, and for the sake of that, again we are using the different types of the AC motors, different types of the DC motor as per their requirement. So friends, now we can discuss about the selection of motors for a crane and hoist. So friends, in the industry we are using the different motors for the crane and hoist. So why we are using the crane? For driving a load from one position to the another position along with the hoist application. So for the selection motors, we want to get a criteria for that the particular motor which will be suitable for the crane and hoist. So the first criteria that will be very important, that the motor that we are selecting for the crane and hoist, that should possesses the high starting torque. So friends, depending upon this is the first and very important selection criteria while we are selecting motor for the cranes and hoist. So it should have high starting torque. Why we will require a high starting torque? Because in case of crane and hoist, we want to lift and move that the object from one place to another place, and for the sake of that, it should have a high starting torque. Then the second selection criteria, that is low starting current, because obviously while we are dealing with the high starting criteria or the torque capability at the starting, that should be high. So depending upon the torque and current characteristics, that should possesses a low starting current. So this is the second important selection criteria while we are selecting a motor for crane and hoist. The third selection criteria, the motors are designed to withstand stresses due to frequent start and stops and reversal. So friends, as we know that in the applications of crane and hoist in the different types of the industry, we should require that is frequent start and stop, and sometime we will require a speed reversal, so that the motor should withstand stress. So that will be the very important criteria while we are selecting a motors for a particular application. Then the next selection criteria is the motor should have rapid acceleration, because for a very short duration of time we want to move that the object from one place to another place by the means of the crane and hoist. So the motor should have a rapid acceleration criteria for a crane and hoist drive. Then obviously while we are selecting a motor, that the motor should possesses a good electrical braking characteristics, because as we know that a lot of energy will be wasted in concern with the electric braking. So if we are using the different types of motor with the help of the different type of the braking, so the energy saving will be done. So this is the selection criteria while we are selecting a motors for a crane and hoist. So friends, let's we can understand what are the different types of the motors that we are prefer for a particular characteristics of your cranes and hoist motor. So basically, as we seen that there are the different types of motor that we are using for the crane and hoist operation. So basically we are using either AC or DC motor. So obviously now we can study which type of DC motor that will be required for the crane and hoist motor. So we have seen the first type of motor that will be called it as a DC motor, and in spite of that particular DC motor, that we are having a different types which will be called it as shunt motor, series motor and compound motor. So basically according to its the characteristics for a particular application, as in crane and hoist, we are preferring a series motor. While we are selecting series motor, because the series motor will possesses a very high starting torque. So for the sake of that, we are using for the crane and hoist drive, we are using or selecting a series motor. So previous days there was a control of the series motor by means of the different types of the mechanical switching, but nowadays we are using the different types of power converters, or different types of the power electronic devices, that we are using the different types of thyristor, or we call it as a power converter. It is possible to do various types of the torque control during the starting, running and braking condition. So that's why we are preferring the DC series motor for a crane and hoist drive. So friends, as we've seen that there are the different types of the disadvantages of the DC motor. So due to that, in the some of the applications we are preferring the AC motor. So what are the different type of the AC motor that we are prefer for the cranes and hoist drive? So we are preferring some of the time squirrel cage induction motor, sometime we are preferring slip ring induction motor. So when we are preferring the slip ring induction motor, so there should be a requirement of the high starting torque. If we want to just change the positioning system, that time we are using for the special purpose application, we are using the squirrel cage induction motor for your crane and hoist drive. So why we are using the squirrel cage induction motor and slip ring induction motor in spite of the DC motor? So there should be a very important reason, and that the reason will be called it as the lower inertia and simple and economical construction of the cage motors favor them as a crane motor, because it's a lower inertia, because as we seen that the weight of that particular DC motor will be larger, the inertia will be larger, the AC motors will be weight will be less, the inertia will be less. So that's why most of the time now we can prefer the AC motor for your crane and hoist drive. Friends, now we can understand in detail why we are selecting a DC drives for a crane and hoist. So what are the different characteristics, what are the different properties, what are the different features that will be required while we are selecting a DC drives for the cranes and hoist? So this is the another type of the very important bit of your discussion, because we have to get the actual applications of these cranes and hoist for a particular reason. So obviously we are using the DC series motor that we had already discussed earlier. So why we are selecting this DC series motor? So these are some of the features that are very useful while we are selecting DC drives for the cranes and hoists. So the first feature will be look like that the DC series motor will possesses very good starting torque. So as we seen that from the fundamental equations of the series motor, so this series motor will possesses a very good starting torque for your particular application. Then the second important part, that is high torque capability. So due to that, the DC series motor are preferred at lower speed and light torques at a higher speed. So as we seen that this is a very important property that will be useful for the cranes and hoist. Then the second features will be called it as electrical braking is possible basically even at a low speeds due to low critical speed. So while we are selecting this DC series motor for a particular application, the creep speed will be possible in concern with the DC series motor. So that's why we are preferring the DC series motor for a particular applications. So friends, as we seen that the DC motors are used for hosting and lowering, where smooth and precise at that time fast speed control is required. So as we know that the DC drives will give you a wide speed control range, because this is beauty of the DC drive. So for the sake of that, again we are preferring the DC series motor, and obviously DC series motor will using the different electrical braking system, and for the sake of that we will get a better acceleration as well as retardation. So that's why we are preferring the DC series motor for a particular application. So as we seen that where we can use this particular DC drive, so basically these DC drives that we are using for the different applications, such applications will be called it as a different DC series motor that we are using for the steel plants. We are using these different DC drives as in cranes and hoist in the different types of the powerhouse and different types of the concrete dams. So for the sake of that, we are using a DC series motor as an crane and hoist. Now friends, we are discussing, because as we have the basic fundamental concept of the drive, because drive is called it as the system employed for motion control. And as we seen that while we are designing a DC drive, we are using the DC series motor for the crane and hoist. So obviously while we are using the DC series motor for the motion control, then it is called it as the DC drive, which will be applicable for your crane and hoist. Friends, so we have to understand the basic block diagram of your drive. I think everyone has got the clear idea. So there are the different types of the blocks which are present in that particular system, and that the block will be called it as, some of the block will be source, power modulator, motor, load, sensing unit and control unit. So this whole combination will be treated as a drive. And friends, it is a series drive, so we are using the series motor. And for the sake of that particular, we are using some of the type of the power modulator, because with the help of that particular power electronic devices itself, we have to control the motor. So friends, as we seen that as shown in figure, we are using one type of the rectifier which will be used for the controlling of the series motor. So friends, as we seen that this is a rectifier which will be convert that the supply. So this is a rectifier which will be convert, that is the alternating current supply, into direct current supply. So as we seen that as shown in figure, we are using one type of power modulator. So this is the power modulator. So what will be the function of that particular power modulator? We have the basic fundamental concept. So this power modulator will changes depending upon its different types of the supply. Suppose the supply is AC and we want to the DC motor, so obviously for the sake of that, this power modulator will convert that the alternating current supply into a DC current supply. And this is representation of motor. So what do you mean by the representation of motor? Because as we seen that this is a series motor, and for the sake of the series motor, we are using its a basic element. So that the basic element will be resistance, inductance and the supply that will be required for your DC series motor. So obviously as shown in figure that we are using the different types of the power modulator circuit. So this is the drive circuit that we are using for the series drive as a cranes and hoist. So these are the waveforms. So as shown in waveforms, friends, we are getting the different types of waveform. This is a voltage waveform, this is the current waveform, and this is the EMF waveform. Okay, so friends, as we seen that this is the function of current into speed. So as we seen that this is the input waveform. So at that particular period we are using the two thyristor and two diode, while we are giving the cycle of the supply to the T1, so that the current will be flowing through that particular T1 to your load, and it will be dissipated from the D2. Okay, so this is for the first cycle. So obviously in case of that, we are using the operation of the T1 and D1 itself. So before we going to start, these the two diodes are called it as freewheeling diode. So this D2 and D1 operation, or D1 and D2 operation, will be showing look like that. So the main output or the first cycle that we are conducting, simple, the T1 and D1, so that the output voltage that we are getting across the DC series motor for the T1 and D1 will be showing in that particular waveform. Again, there should be a freewheeling interval of the D1 and D2. So this is the period at the D1 and D2 will be operate. Again, for the second cycle, that the T2 and D2. So the operation of that particular T2 and D2, now we can draw. So we can draw this operation of the T2 and D2 as well. So for the sake of that, we have to understand what will be the operation. So first of all, now we have to change the supply terminal of the T2 and D2. So now we are conducting, now we are giving the voltage of that particular the second cycle. This is basically that we are giving the supply to that particular T2. So now we are changing the direction. So now we are giving the supply in spite of this. So this current will be flowing through T2. So from that particular load to D1, because we have to change the direction of this particular supply. So we are getting the output, that is T2 and D2 across that particular terminal. So this is the operation of your DC series motor drive, which will be preferred for your applications of cranes and hoist. So this is one of the control method. And the another very popular control method for the driving of the cranes and hoist drive. So this is called it as wide Leonard system. because friends we have to get the speed control at acceleration as well as retardation. So most of the industry we are preferring that is Watt Leonard type of the drive for a particular applications of the cranes and hoists. So friends, what do you mean by the Ward Leonard drive? So Ward Leonard drive will be providing you the speed control that is below base speed, below base speed as well as above base speed. So we have to control the speed of that particular machine that is for below base speed and above base speed by the use of the control rectifier. And for the arrangement of the wide Leonard system, we will require a separate machine. So this is the AC supply that we are giving to your AC motor. So friends, there are the certain disadvantage of the wide Leonard system, because the cost of this system will be very large, because we have to control the speed of this particular motor. We have to use a two separate machinery. First machinery will be called it as a AC motor, and second machinery will be called it as a DC generator. So friends, while we are giving the supply to that particular AC motor, this AC motor will be coupled to your generator. While we are changing the supply voltage of your AC motor, then obviously the voltage of that particular generator will be changing. So obviously while we are changing the voltage of your generator, so this again generator will be coupled to your motor. So while we are changing the supply voltage of this particular motor, this motor will changes the voltage of that particular generator. The generator is coupled to your motor, so this generator will be again changing the armature current, or we call it as, it will be changes the armature voltage of this particular machine. So we are getting the speed control of that particular machine that is below the base speed. And for the driving of that particular DC generator, we are using, or we are getting the different type of the AC supply from the mains. So this is the AC supply we are getting from mains, and this is the rectifier which will be converted, that is alternating current supply into direct current supply. And this is the field winding of your DC generator. So we have to control the basic armature supply of that particular generator. So we will get the controlling of the speed control that is below the base speed. Suppose if you want to get the speed control of that particular drive for the above the base speed, so we are using one changeover switch will be there. So as we seen that if you want to do the speed control above the base speed, so then obviously we are preferring the speed control method that is called it as field flux control. So obviously while we are getting the speed control that is the above the base speed, so again we have to give that particular AC supply to your controlled or uncontrolled rectifier. So this the rectifier will be again converting that the AC supply into DC supply. Now this DC supply will be given to you the field winding of your motor, and while we are changing the field winding of that particular supply by the changing of this particular switch, so we can get the speed control of that particular drive that will be called it as above the base speed. So friends, this is a wide Leonard drive that will be preferred in the different types of cranes and hoist in the different industry. So friends, this is called it as a DC drive which will be preferred for your application as in crane and hoist. So now we can understand why we are preferring the AC drives for cranes. Nowadays friends, as we seen that there are the different types of the disadvantages of the DC drive. So in spite of that, we are using AC drives for your crane. So as we know that friends, in the different applications of the AC drive, we are preferring both the squirrel cage induction motor and the slip ring induction motor. But friends, as we seen that there are the different disadvantages of the slip ring induction motor. So while we are comparing the squirrel cage induction motor and slip ring induction motor, while we are designing the different types of cranes, especially we are using the squirrel cage induction motor due to its different features. So what are the different types of feature that we are using? So friends, as we seen that there should be a no speed control is required. However, with the development of variable frequency converters which solve the problem of speed control of induction motor, so the inverter feed motors are used to situations requiring wide range of speed control. Because as we seen that friends, in the different type of the applications of cranes and hoist, we will require, there should be no requirement of the speed control. In spite we are getting the applications of cranes and hoist for a particular application. So by the use of the variable frequency control converters, we are preferring such types of the AC drive for the cranes and hoist. Then should be the second thing, they have fast acceleration and a fixed sequence of operation. So while we are comparing the DC drives and AC drives. So the operation of this AC drive will be very fast than the DC drive. So that's why in the industry we are preferring the AC drive for a particular application. Then the regenerative braking is not problem in concern with the squirrel cage induction motor, because sometimes the squirrel cage induction motor will be used as an induction generator. So these basically automatically happen or occur when the load overhauls or the empty cage is being raised. So this is one of the important advantage of the AC drive while we are selecting for the cranes and hoist. And obviously the motor that we are using for the AC drive, that is squirrel cage induction motor, it is very simple in construction, and the robust, the efficiency of this particular motor will be larger. So that's why in some of the application we are preferring the squirrel cage induction motor for your cranes. So along with that, again we are getting some of the problems associated with the squirrel cage induction motor. So that's why in the industry we are preferring, in spite of this particular squirrel cage induction motor, slip ring induction motor. So what are the different these problems are there? So the first problem that will be associated with the squirrel cage induction motor is that, so these are not suitable when large number of starting and braking are required, because as we seen that when the large number of starting and braking is required, we have to prefer the another type of motor which will be designed for a high starting and braking torque. The second problem, in case of very high starting torque, these are not suitable. So obviously the braking will be larger, the torque, starting torque will be larger, so that's why this is not suitable. Then the third problem associated, that is non-uniform sequence of the operation cannot be handle, and conventional methods of speed control are not suitable if precise speed control is necessary. So friends, as we seen that while we are using the conventional speed control method, so what are the different conventional speed control method? So the conventional method will be speed control method, that is pole changing. Second, by stator voltage control, stator voltage control. And friends, while we are using this conventional method of the stator voltage control, so we are not getting the speed control that is precise according to your requirement. So this is one of the disadvantage. So to overcome these particular problems or the disadvantages, or while we are selecting squirrel cage induction motor for a particular cranes and hoist, now we are preferring a slip ring induction motor. So what is the difference in between slip ring and squirrel cage induction motor? So according to its construction, the rotor construction of this squirrel cage and slip ring induction motor is different. The rotor of your squirrel cage induction motor will be shape of the squirrel cage, and the rotor construction of the slip ring induction motor is a wound rotor induction motor. So basically this slip ring induction motor will be preferred in a cranes and hoist. So why we are using this slip ring induction motor for the cranes and hoist? Because some of the problem are associated in concern with the motors, that will be called it as a squirrel cage induction motor. So friends, in a different types of industry we are preferring a slip ring induction motor drive for a cranes and hoist. So what are the different properties or the features? So the first feature is that the speed torque curve can be modified by suitably altering the rotor resistance, because while we are controlling the slip ring induction motor by means of the rotor resistance control, we can modify its speed torque characteristics, but in concern with the squirrel cage induction motor it is not possible. So that's why these motor are preferred instead of squirrel cage induction motor in a particular application. Okay, the starting torque can also be varied to the required value. So friends, as we seen that while we are using different types of the speed control strategy by the rotor resistance control, then obviously as per our requirement we can change the starting torque. So that's why the slip ring induction motors are advantageous than the squirrel cage induction motor. Then obviously the regeneration is possible in concern with the slip ring induction motor. Then the next feature, that would be called it as a reverse current braking, can be employed limiting the current to the desired value by rotor resistance. So friends, obviously while we are using the rotor resistance control technique into the slip ring induction motor, we are getting various important features. So that is reverse current braking is also possible, it is in a slip ring induction motor. So obviously, and another important concept that we are using. So the DC dynamic braking also be employed. So the DC dynamic braking will be employed while we are using the speed control method for your slip ring induction motor. That is speed control method will be called it as the slip power recovery scheme. So in the slip power recovery scheme, we have to recover the slip power recovery, and obviously the DC dynamic braking also be possible, because as we seen that in the rotor circuit of your slip ring induction motor, we are using a resistance, and due to the presence of that particular resistance, while we are changing the firing angle of that particular resistance, we can get the DC dynamic braking. So this is one of the advantages of the slip ring induction motor. So for a lifting of a heavy load, such applications will be called it as the shipyards. So definitely for that particular purpose, we are preferring the slip ring induction motor drives for a cranes and hoist. So friends, now we can understand how we can control the speed control strategy of that particular slip ring induction motor. So friends, as we seen that this is the three-phase supply which will be available, that is RYB. Basically it is a rotor resistance controlled slip ring induction motor drive. Okay, so this is rotor resistance control. So friends, as we seen that this is a three-phase induction motor. So we are giving the three-phase supply to the stator winding of your induction motor. So this is the stator winding, and this is the rotor. This is the rotor. And as we seen that while we are constructioning, or while we are designing this particular slip ring induction motor, we are using the rotor circuit, we are inserting the value of the resistance. So this is the rotor circuit, and in that particular rotor circuit, so I can draw a simple method or the simple circuit. So this is the rotor. So in that particular rotor circuit, we are just connecting a resistance. So these are the variable resistance. This is the supply. This is the supply, that is RYB phase sequence. So this is the resistance, this is the rotor circuit, this is variable resistance. So in the slip ring induction motor, we have to change this value of the resistance by which we can get the speed control method. Okay, so this is slip ring induction motor. So in that particular slip induction motor's rotor circuit, we are connecting a resistance, but this resistance are connected by the means of the power electronic device. So this is the resistance that we are connecting the rotor circuit of your slip ring induction motor, and this resistance is a variable resistance. So the controlling of this variable resistance is controlled by one power electronic device. This power electronic device will be called it as a transistor. So transistor will having a three terminal. This is emitter, this is base terminal, and this is collector terminal. So friends, the energy that we are getting from the rotor circuit, that will be converted. So it is a uncontrolled rectifier, so it is diode bridge rectifier. So this alternating voltage will be converted to the DC supply by means of this rectifier circuit. So it is diode rectifier. So what is the function of this diode rectifier? So this diode rectifier will convert that the alternating current supply into a direct current supply. So we are getting the direct current supply. So the ID will be the current which will be flowing through that particular circuit. So this is ID. ID is the current flowing through that particular circuit. So now this the DC supply will be having a pulsating DC. So we have to just filter out this particular pulsating DC by means of the inductance, connecting a series inductance coil. So this is one of the type of the filter by which we can get the pure DC. So we are getting the pure DC supply for the limiting of that particular ripples. So friends, now the resistance is connected. So this resistance will having the value of R. And now because this construction is similar to this construction, but in that particular system we are using the mechanical system. Now we are using the power electronic devices. So for the controlling of that particular resistance, now we are using one device which we call it as transistor. So this transistor will having a terminal, that is emitter, base, and collector. and we have to control the value of its a base value. So for the sake of that, we are using one type of drive that is called it as base drive. So while we are changing the value of this base terminal, we can change the value of resistance. While we are changing the value of resistance, we can change the speed control of that particular rotor circuit of your induction motor. So this is called it as the rotor resistance controlled slip spring induction motor drive. Okay, so friends, we can understand the closed loop speed control. So as we seen that we are using one type of the sensing device which will be called it as speed sensor to your system. So this is the speed sensor. So what is the function of the speed sensor? So it will be senses the speed of your motor, and now this speed control will give you the value of the speed of your motor to the summing point. Okay, so friends, now we are taking one of the examples. Suppose the speed of that particular motor will be currently rotating at 2000 rpm, and if you want to change the value of that particular speed of the 2000 rpm of your motor to 1500 rpm. So friends, we are giving the reference signal because currently this motor will be running at 2000 rpm. Now we want to control the speed of this particular motor at 1500 rpm. So this is the reference speed that we are getting, that is 2000 rpm. From here we are giving the input, that is 1500. So from 2000 1500, this summing point will be creating a error signal. So in that particular error signal, so the error signal of the 500 rpm. So as we seen that in the closed loop speed control strategy, we are using the current limit control loop. So what do you mean by the current limit control loop? So this current limit control loop senses the value of the current of that particular drive, so that the value of the current, which will be called it as id. And what do you mean by the id? This is the current in that particular circuit. So we are using some of the speed control strategy. So this is the speed controller. What is the purpose of this speed controller? This speed controller will convert, that is a 500 of speed, into the required quality of your current. So we are changing this, the value of the speed into the value of the current. So we are getting, suppose at the time of the 2000 rpm, the value of the current will be 10 ampere. Okay, so this value of the current will be 10 ampere. But if you want to change the value of the speed, that is 1500, so according to its error signal, the speed controller will convert the, or the change, or the limit the value of this particular current circuit to its limit circuit. So for the sake of the 1500 rpm, we have to give the current that will be called it as the 7 ampere. So depending upon that particular, this current limiter will limit the value of the current according to your value. So this summing point again will compare the value of the 10 ampere current, 7 ampere current. So this the summing point again, which will be generate the signal of the 3 ampere, because as we seen that the current value is 10 ampere, we have to control the speed, that is limited the speed, we have to drop the speed by 500 rpm. So we want to limit the value of the current up to the 7 ampere, but the rated current is the 10 ampere. So this error signal will generate a 3 ampere current, and now this 3 ampere current will be given to your current controller. So this current controller will control the value of this particular 3 ampere currents, and depending upon that the 3 ampere current, it will be give the signal to the base drive. So in the base drive, this is a transistor. So basically the transistor will be operating on the basic duty interval. So what do you mean by the duty interval, or we call it a duty cycle? So we have to control the value of del. So it is total time period, that is t on, by total time t on, that is the on period of your circuit, and divided by the total time period t. So for the sake of that, we have to control the base value. So according to that, the 3 ampere current, this base drive will generate a duty ratio, called it as duty cycle, of the required value of your resistance. So depending upon that particular value of your 3 ampere, so this base drive will generating this signal of the duty cycle. Okay, So depending upon that particular signal, so it will be changes its base value. Suppose we are changing its base value, so depending upon its base value, this drive or this transistor will change the value of the resistance. So if the value of the drive will be changing, it's the value of the resistance, then obviously now this drive will be operated at 1500 rpm. So this is a closed loop speed control strategy of your rotor resistance controlled slip ring induction motor drive that we are preferring for your cranes and hoist. So this is one of the method of the controlling of your cranes and hoist drive. Now we can understand and discuss very popular method in spite of that particular rotor resistance control, because this rotor resistance speed control strategy which will be having various disadvantages. So that's why for the controlling of both squirrel cage as well as slip ring induction motor, we are using one drive which should be called it as VFD, that is variable frequency drive. And friends, as we've seen that nowadays in any type of industry this is very popular, because as we've seen that in the industry near about the 80% motors are the induction motor, and for the controlling of that particular induction motor we are preferring this type of drive which will be called it as variable frequency drive. So friends, as we have seen, there are the different advantages of the variable frequency drive, because from the use of the variable frequency drive we can get the speed control, because this variable frequency drive speed control strategy is very simple. We are using different types of converters, so that's why the operating voltage, operating frequency, and the operation of this drive will be very smooth. So that's why we are preferring this type of drive for a industry. So in that particular variable frequency drive, the name itself indicates its a meaning. So this is the actual model of that particular DC drive that we are basically used in the industry. So these are the control panel, this is a display screen, so by which we have to change the value of the frequency by which we can get the variable frequency control. So this is the induction motor. This induction motor may be your squirrel cage or slip ring. So obviously for the sake of that we are using this strategy. So friends, suppose we are having the supply voltage that is RYB. So this is supply voltage R, this is supply voltage Y, this is supply voltage B. So this is the AC supply will be given to your diode bridge rectifier. So what is the diode bridge rectifier? Again it will be convert the AC supply into DC supply. So this DC supply is not pure DC, it is pulsating DC. So we are using one filter circuit by which we can filter out the DC supply and we are getting the pure DC supply. So we are connecting one capacitor for getting a constant voltage. So maybe this will be the VSI, that is voltage source inverter. So what will be the purpose of this particular inverter? So the purpose of this particular inverter will be look like that. It will be convert that the DC supply into AC supply, and this AC supply will be given to your induction motor. Maybe the induction motor will be squirrel cage or slip ring. Okay, so this is the one of the power modulator. And friends, now we can understand what do you mean by the variable frequency drive. So according to the basic fundamental equation, that is voltage is proportional to the frequency into flux according to its basic fundamental thing. So we have to maintain the ratio, that is V by F ratio constant, for the getting constant the value of the flux. I think we had already discussed why we want to maintain the value of the constant flux constant, because of the certain reason, that is saturation and the losses. So we have to keep maintain the ratio, that is V by F. So that's why we are preferring the variable frequency drive as a speed control technique. So friends, this is the inverter circuit and we want to give some of the input value, because while we are changing the firing angle of that particular inverter, we have to control the speed of this particular induction motor. And for the sake of that, we have to give some of the reference value of voltage and frequency to that particular inverter circuit. And now this value of the reference value of the voltage and frequency which will be given basically from the speed reference, because if you want to draw the speed control strategy of the variable frequency drive, so it will be similar, look like a different speed control strategy of your induction motor, but according to your speed reference we have to change the value of voltage as well as the frequency. So what do you mean by the voltage and frequency? We have to keep that the ratio of your variable voltage as well as the variable frequency. So we have to keep the ratio, that is V by F ratio, maintain constant. So friends, we are giving the input signal to your inverter. So what do you mean by the inverter? So the inverter will be device which will be convert that the DC supply into AC supply. So in that particular inverter, again, depending upon the different types of the power electronic devices, we are using some of the power transistors, some of the using power thyristor for the manufacturing of the inverter. So this inverter will inverts the supply. So this inverter will convert that the DC supply into AC supply by means of the changing its different states. So we are getting the output, that is the AC, and we are giving the reference signal of voltage and frequency. So friends, if you want to change the value of the speed of that particular induction motor, just we want to change the value of the frequency by keeping a voltage constant, because while we are using the variable frequency drive, again we are getting the speed control, that is below the synchronous speed and above the synchronous speed. What do you mean by the below the synchronous speed? Because as we've seen that these are motors are rotated at the synchronous speed, as we call it as the value of ns. So if you want to control a speed control of your motor, that is ns. If you want to speed control that is above the synchronous speed and below the synchronous speed, this speed control strategy will be possible. So if you want to do the speed control above the speed or below the speed, just we have to change the value of this voltages and frequency, so by which we can get the speed control of above the synchronous speed and below the synchronous speed. So that's why the variable frequency drive will be very very popular in the industry because of its various advantage. So friends, in this way, in the industry, if we are preferring the AC drives for a cranes and hoist, then we are preferring a VFD method for controlling it. So in this video, we have detailedly study which type of the DC drives, which type of the AC drive that we are preferred for the different types of the cranes and hoist for a particular application. Thank you.